Testing. 1, 2, 3. Testing. Okay, I think we are online now. And hello, Rodrigo. Can you hear me?
Yeah, hi Alan. Hi guys. Nice to be back here.
Yeah, really good. So, did you set up your camera? I cannot see it.
Oh, sorry. Yes, I did. Sorry for that. Let
Yeah,
me open
mine is
the
not
cover
enabled,
here.
but
Yeah, but that's okay. I can open here. Just find the. Okay,
yeah, good.
let me put
Um,
some.
what is the idea for today, Rodrigo? What do you plan?
So for today, we are going to add support to our board to the LCD 16 by 2. Is I think I can show you.
Yeah,
Is
matrix
way better
LCD, right?
to.
A segment
Yeah.
LCD.
So let me show my screen and I can start the. So basically, you have a LCD like that one here.
Yeah.
And if you see, this LCD has a proprietary interface here. This 8T44780 parallel interface is a very old chip, but we're still using that. And they use 8 pins to communicate with this module, but in fact there is the possibility to use the 4-bit mode or the 8-bit mode. To be
Hmm.
honest, I never seen anyone using the 8-bit
Great.
mode,
Yeah.
just the 4-bit mode. But to help us not to connect uh, too many pins or too many wires, you are using this backpack, right? So basically, this backpack goes. I think I can show the camera,
Hmm.
and
Yeah. It.
I'll try not to mess my setup here while I show you guys. Let's see if I can do that.
Hmm.
But basically, the backpack goes back in the LCD, and we solder to the LCD pins, and then you can use the I2C interface to interface with the LCD. That's the idea for the backpack.
Yeah.
And the backpack, I think they use if you can see here, the
Is IO extender. IO
P,
expander.
yeah, PCF 8574.
Yeah. These are
So
NXT.
yeah, so is this chip.
Yeah. Is very common, and yeah. Actually, the Arduino guys use it a lot for this kind of um, IO expander, and also to LCD as well, to a segment
Nice.
LCD like this, the matrix LCD. Yeah.
So I'm already showing. So let me. So here we have the connection that I did. So the ground and VCC as usually, and I'm connecting to P. Let's check here. Is
I think PB8 and PB.
PB7 and PB8, right? Yeah.
Yeah.
So
Cool.
that is the
Yeah, and you are using 5 volts to power it up instead of 3.3, right? Because
yeah, because
it has some
this module
voltage
here, if
regulator.
you put yeah, if you put 3.3, they will work, but it's very difficult to see
The display.
the display
Hmm.
because I think they don't have enough power to show the pixels well. So we need to supply 5 volts for this one.
Yeah. Cool.
And okay, so that's the hardware. So let me show the the NuttX part of this live. So uh, in fact. uh, this module, if LCD backpack is already supported in STM32 common,
Mm-hmm.
it's already here. That's nice for us because you don't need to to include these files in the common. It's already here, and we just need to add this. So as it is already in common, you just need to add that in your bring up.
Mm-hmm.
So when the board brings up, the board power up, they you initialize this driver and you can use the application to test it. So let's go to our board. I think you can copy from, let's see, not sure if Discover has this one. I can try to find here. Source.
Yeah, it's
Uh, yeah, it's Hub, so I use that as reference. So first I need to include the .8, right?
mm-hmm.
It's in common. So let's go to our board. And I think I passed it already. No, let me close this one. It's here. Yeah, it's here. So here in the our board, in the bring up, I need to add this.
Yeah,
Okay, I need to add this here. And then after include the header, I need to initialize the board.
right.
Very simple today, guys. So bring up, there's a lot of this that you already did, right? So I put in the end. Okay.
Yeah, and
So just regarding the interface here for
yeah,
initialize
the
the
the parameters right to the
yeah.
backpack.
So here you are saying that you have the drive mounted at SLCD0, right?
Yeah, the device number 0.
You're using the I2C run, and you have two rows in this LCD and 16 columns,
Right.
right? So that's how we. So I think there's another common LCD similar to this is 16 by 4 rows. So in case someone are using that, just need to change that for 4.
Yeah, and
And I
also
think
the
there,
I2C bus, right? If you decide to use a different I2C bus, for example,
yeah,
I2C2, you need to
mhm,
change the second parameter from 1 to
yeah,
2, for example.
yeah, that's right. Okay, so I think for code is short today.
Mm-hmm.
At least I don't remember anything else. Let me double check in
Yeah,
my annotations here.
maybe
But I
a good idea, Rodrigo,
hmm
is also to enable the I2C tool to search for the device in the bus, just to, for example, imagine someone are trying to get it to use it, but he is not configuring it correctly. Maybe the I2C pins uh, are not, for example, someone messed with these pins. And also, I think some boards have this packed board have the uh, S clock and S data inverted. So sometimes it's a good idea to double check as well, right?
yeah. So uh, let me do the following just a second. I'm trying to buy some running shoes, so they keep showing that. So sorry for that. But yeah, so it's important to say. in some case, I think Alan see that this SDA and SCL, the data and the clock from I2C, they are inverted in the board. So if you guys are having problem to scan the bus and to identify the I2C device, maybe you can try to swap this
Yeah,
these two here. In my case, this is right. So the label here is correct, and I can connect it accordingly in my board. But anyway, if you guys have any problem, try to do that. And regarding the I2C2, yeah, you can enable that in the config, right? I think
yeah,
don't need any code change, so you
yeah.
can do that.
It's just few configurations, right? So it's
Hmm.
easy to test.
Okay, so let me
Yeah.
go to the
I think now
terminal.
that you did it, we can return to the terminal and
Hmm.
configure the board to NSH
Yeah.
or USB
Hmm.
NSH to make it simple, right?
Yeah, I think yeah, I think I use the uh, uh,
You need to
I
check the you need to change the
what's
board.
the command to autocomplete the
Configure underscore autocomplete.
conf, conf, configure?
I think that's that. Press tab to see the options.
Yeah,
Tools.
it's not showing. So, oh, sorry,
Maybe autocomplete. Uh,
tools. Okay, configure
no, maybe the name is different. I'm not
this
using
one.
too many times, but let's see.
No, that's okay, no
Yeah,
problem. So
yeah,
let's do the form. Uh, I think to list the boards here, we need to.
yeah. I look in here in this file and I try to find it, but um,
Oh,
it's something like autocomplete or maybe they changed it already.
let's do the following.
Yeah, I cannot see it here in that listing.
Hmm.
Probably someone because things are
Whoops.
change all the time, right? In
Yeah. Okay.
configure autocompletion.bash
So configure.
underscore
Ah, okay.
autocompletion. Sorry, completion actually. Just
Uh,
press tab.
not sure. But I'm not. In fact, I'm
Ah,
not in the latest now. So maybe that's because that.
maybe because it's not executable. You need to type dot space
Hmm.
the yeah tools configure underscore yeah
Oh
this
yeah.
one yeah now
Ah,
when
okay.
you type tools dot slash tools configure SA when you start STM32 F4 it will show these options just press tab twice
Nice.
press and
Yeah.
you see the board name
Hmm.
it was Gustavo Nihei that created this script it's very useful.
That's nice. That's nice.
Now you
So
press tab and it show the
yeah,
options. Yeah,
yeah, that's nice. So guys, uh, that's the command that you need to do to have this facility. And as we support a lot of boards, I think it's worth to do. Uh,
yeah. It makes the finding the configuration and the board name more easily.
mhm. So let's go for that and make new config.
Hmm.
Okay. Uh, I
Build
for
build
let
setup, right? Go to peripheral build
yeah.
setup.
First need
System
to
type. Yeah, you're right.
the STM32 peripheral support. So of course you need to enable the I2C one. That's one that we are using.
Hmm.
I think for here there's nothing else.
Yeah, I think
Uh,
George just come in the meeting. Hey George, hey George, how are you doing?
Hello, Alan. Hello, how do you?
oh, hey, Jordan. Nice to have you here. Uh,
Yes.
could you check if the live is okay in the YouTube, please, George? I tried to check here, but then I start to.
Okay, I check here. Always okay.
Oh, thank you
Thank you.
so much. So let's continue here.
Now go
Uh,
to device drivers.
yeah. Uh, can I enable the common support board
Oh
support
yeah,
before?
that as well.
Uh,
Common
because
board
you are
common logic.
the mhm. As the the support was added in STM32 common, so you need to select this one too.
True.
And now device drivers,
I
I2C
I2C
drive
driver.
support.
Yeah.
Yeah,
Enter
I
inside
think here
paths.
don't.
Also enable the I2C character driver.
Okay, okay. And anything else here? I think that one.
No, that's
Yeah.
all.
So now the LCD drive support,
Mm-hmm.
alphanumeric segment LCD,
Correct.
and we need to use this. This is
The
the
backpack.
backpack, so we need to enable that. Uh, I think that's all from here. And now we need to go to library routines.
Yeah, but
I
I think
have some.
yeah, this one is
Oh,
already enabled. At least was enabled by default, right? It was the codec.
yeah. Let's double check. Yeah, it's enabled. That's right.
Segment.
I missed the I2C two.
Is application. You need to move down.
Just in the application. Okay. So okay, in the application, uh, let's first enable the example for the LCD,
Mm-hmm.
and it would be what's the name? Segmental LCD test. Segment LCD test, guys.
Yeah.
Should be in the end. Okay, almost there. Okay, yeah. So here is the so there in the interface to initialize the LCD, if you change here the device number, let's say if you put one here, in the configuration you need to do the same, right? So you need to go
Yeah.
here
Good
and
point.
change
You
to
need to
one.
change this device, the LCD device path.
Okay, so I think I have just one more here that the in NSH library,
Yeah.
but it's enabled by default. How
Yeah.
about the I2C2? I don't remember that, sorry.
Move down. I think is NSH and add-ons. Move down.
Okay.
The system
Okay.
libraries NSH
Mhm.
add-ons.
Okay. I2C2.
Yeah.
Okay.
And
Any
yeah,
config for that?
you can, since we have only one bus, you can put the minimum as one and the maximum as one because we have only
Okay.
I squared C1, so
hmm
it's easier to avoid
Okay.
mistake. The remaining is correct.
Okay. Just to the, I think, so this one here, just to double check, but I think it's enabled by the, so it's this one, right?
Mm-hmm.
Have architecture specific initialization, so it's okay. Uh, Anything else? I think,
I think that's all.
yeah. So let's try it. Okay, that's a good start. It didn't fail. So now you put the device in boot mode. Uh, you can check that here. Okay, it's here. And now you can use the DFU to flash it. And I'm going to reset the board. Okay, it turned it off. It's a good sign, right? Because it's in.
Hmm.
And now I use Minicom. And I'm not sure which configure it. I think yeah, the ACM0, it's right.
Yeah, it's correct.
Just go through the, okay. Uh,
You can run the I2C2, right?
so uh, that's now, right? So you are
Hmm.
bored. Uh, so it's I2C.
Sorry,
Uh,
I2C bus,
sorry,
I, I squared C space bus.
bus. Just the number or
No, just to scan, it will see the bus numbers.
okay? Sorry,
Type
but I
I
need to
squared C
pass in.
without parameters, it will show the options, so it's better for
Okay,
if you are not
okay,
sure. Yeah.
okay. Okay. So I2C minus B1. That is bus one. I didn't.
So, try I squared C bus initially just to confirm the I squared C1 is here.
Hmm.
Yeah. So now you
Okay,
can
I
press
got.
um, I squared C dev because you want to list all the device.
Does that?
Space space uh, dash B1 as you type there, the buzz one. No,
So
dash
okay. So
space dash.
dev.
No, no, no. Dev is correct.
Uh-huh.
Space um,
Hmm.
dash B space one
Hmm. Okay,
space
that's right.
the yeah space 0x the initial address. For example, 0x03 or 00. Normally is
Hmm.
yeah 03 and 0x7 7f.
I'll take note of this one.
I think
Let's
that's it.
check.
Yeah, let's see.
Okay,
Yeah,
I'll take note of this one. Okay.
yeah,
So in this board you have the memory and the temperature sensor in the same bus. That's why you have three of them here, right? So I'm not sure which one, but I think
yeah. I think that is
this one.
48. Yeah, exact.
Yeah.
Yeah. So it was
And
detected.
so
Now
now it's time.
we can run the SLCD to
Mhm.
initialize and see the message in the SLCD.
Yeah. So let put this a little bigger, and let's do that. Okay.
Hello.
So they print.
Yeah.
They some. I think the only thing is that the application right now, if you run this again, then you put that in the second line. So
Ah, yeah. It print again in a new line.
yeah,
Exactly. And you, I
but
think also you can pass some parameters, right? SLCD testing, for example.
Uh,
I'm not sure if
else
it's still working, but I think that's it. Quote,
testing.
double quote,
Okay, so you pass a string, right?
yeah, like in string, testing,
Okay. Hmm.
yeah, that's it.
Nice. Oops. Okay. Hello, NuttX. Oh, double quotes.
Yeah, it
They
put maybe because,
something got messed here. Yeah.
yeah, maybe
But
because,
that's okay.
yeah, cool,
So that one was fast because the support is already in the common.
yeah,
So just a little of code and some configuration that as usually I mess it up, but thankfully Alan is here to help. So
yeah. I think
yeah.
uh, try to say help SLCD. I don't remember if it has
Hmm.
some help, but maybe it has. So that's some other no SLCD dash 8 like for help. I don't remember if it has help. No, it doesn't.
They print the
Yeah, it put the message
as
there.
a, as I input. Yeah.
Hello, help. Cool, very nice. And in the here in the NuttX channel, we have also a configuration to get the NSH running in the SLCD in this display.
Nice.
So for example, imagine you want to create like a small computer and you don't want to use your computer to interface with NuttX over the serial or USB like we are doing today. You just want
Hmm.
to use the microcontroller as it was a real computer. So you can show the NSH there, and you can use, for example, some keyboard, USB keyboard, or maybe implement some PS2 keyboard or something like that. So
Hmm.
you can uh, you can use the microcontroller and use the NSH as uh, user interface, uh, uh, like a text user interface like DOS or even Linux shell. So it's very cool.
Nice, nice. So uh, I think that's all for today, né?
Yeah, it's very cool, very nice.
That that one's a little fast. As I said, the common support's already there, but guys porting uh, for the other platforms may just need to do some additional steps. That is to copy the
Yeah, the initialization from other boards.
yeah
Very cool.
yeah
Okay.
in the source they just need to copy this file here and the 8 file, the header file, and adding the bring up. I think we did this a lot of times, so the guys should know that.
Yeah, very cool. Okay. I I think that's all for today, right? You have some other.
No, I think that's all. Let's keep the order for next week.
Yeah, cool. Okay. Thank you, Rodrigo. Thank you, Josh, and thank you everybody for being here to watching this live, and see you in the next live.
Okay, bye bye.
Bye bye.
Okay,
See
bye
you.
bye.
Bye bye, Josh.